Next, let's move on to composite data types. In Python, there are 4 very important composite data types: list, tuple, set, and dictionary. I would personally say that list and dictionary, they will be much more important because we tend to use them a lot in plenty of commonly encountered programming situations. That is followed by tuple, and then eventually also the set, which is important in its own right. Otherwise, it would not have been included in basic Python language support. However, in terms of actual usage, I personally would use set far less frequently than the first 3. And between the first 3, I would use list a lot more frequently than dictionary, which is much more frequently than tuple, and then followed by set. So roughly in that order. Now, what are composite data types? Composite data types are basically non-scalars, and more importantly, they are having some sort of a structure to contain scalar or composite or structured data types. So it is a data type that contains other data types. That's why it's composite. It's allowing us to compose more complicated structures on top of existing data structures that we have. So for example, if Python can only deal with scalar data types, then it will be very tough for us to use Python language to describe the concept of subsets, right? One thing is contained in another. So for example, let's just take a piece of paper that we write something on. So if we take a piece of paper and write a 3, so we now have an integer 3, right? So this piece of paper physically is an integer 3. If this is all the kind of storage structure that we have, paper by paper, then we are kind of in a mess. We have a lot of loose papers. How nice it would be if we can have a bunch of integers, because these bunches of integers, they describe the number of dollars that I have on different days. First day, I have $3. Second day, I have $5. Third day, I have $8. Fourth day, I have $6. I earn some and I spend some, something like that. So it would be nice if I can hold them in some sort of a sequenced structure, page by page, right? And of course, we are thinking about why don't we, staple them together into a book? And that is a structure. That's a structure. Why? Because all these integers, the sequence have some meaning to us because it's day 1, day 2, day 3, right? So it will be a problem if we try to memorize the structure. 6 comes after 3, but it's stored before 3, and that would be quite a mess. So it would be nice if we can staple them together and bind them together as a book. And that's where list comes in, right? So the list allows us to have an ordered sequence of any values. And this any value, whether it's scalar, composite, or structured, is a very powerful feature. Because when we think about book, we tend to think about pages by pages of similar size, A3, A4, all stacked together. But list is, the analogy goes only that far, because list can store any data type. So we can have some A4 pages. On weekends, we might have more businesses, and we need to record it on an A3. And yes, you can also stick in an A3 in our book, in our list structure. Or you can also have, because A3 is just very large, and you are going to cut A3 into pieces, and you have a lot of transactions, and you want to sort of staple the weekend transactions as a small mini book and staple it into a larger book. That is okay too. So list can contain a list, right? So list can contain some numbers, some floats, some lists, and then sets and other classes that we created, and that's fine. Very, very powerful. So it allows us to really string all the data types together in a ordered sequence. So the sequence has meaning. The sequence allows us to also have repeated values. All right, so we can store 3, 3, 3, and that's fine. That will be 3 3s, because the repetitions are significant to us. They are important, for us to record the fact that 3 actually is highly frequently observed, right? And things like that. So we may use the list as a homogeneous type, like all are integers, or we may use them as mixed. So Python is very flexible in that sense. Of course, there are some of you may recognize that there may be efficiency impacts and all that, but that's not the main thrust of our discussion here. We are talking about the usage and the flexibility here, and list allows us to do that. Then just very quickly to cover all the understandings before we dive into the experimental lab in Spider. Tuple, think of it as a immutable list. Immutable means cannot be mutated. Mutated means changed. So the contents of a list can be tweaked. So 345 can be changed to 355. Or 345 can be truncated to just 3 and 4. That's all. But a tuple, once created, cannot be changed. It's immutable. And there are a lot of reasons why we may want to do that. And having a language that supports immutability guaranteed system-wide within Python is a very nice feature, because we might not want our encryption key to be mutated, right? So a lot of times this is not guaranteed. Hackers can always issue special overwriting functions to write over the data, but not for tuple in that sense. I'm not saying tuple is a protected kind of structure. I'm just saying that it's guaranteed to be immutable, allows the communication to become safe, that you feel, in fact, that Python will ensure no commands can change it. Now, it doesn't have to be encryption, decryption. It can also be communication, because you might be writing a module and allowing for some variables to be modified by the caller. But there are certain variables that whose literals, whose constants, that you really don't want them to be changed. Otherwise, it'd be disastrous. It might be overriding file instead of reading from file, and so on. So in that case, it might be better to hold the constants in a tuple where it will not be changeable, right? Nobody can change it, guaranteed by Python. So that would be a very nice feature that I can think of using tuple, read only. Otherwise, all operations supported by list, in terms of accessing, in terms of reading, in terms of scanning, searching, and all that, except writing and mutating, changing it, they are all also supported in tuple data type. Next is set. Now, I did stress that all values in list, they can be repeated. They are also ordered. They are listed in ordered sequence. A tuple is also ordered. That means the sequence matters, and you can repeat, but it cannot be written in too. A set is mutatable. You can change things inside. It has to be only unique values, and that is guaranteed by the set operation itself. That means even if you type, I want a set of 3, 3, and 3, and Python will only understand it. There's no error, but Python will understand it as, okay, store the value 3 in this set. That's it. Because all values in a set mathematically is unique. All right. So also, it is unordered. So there are 3 characteristics of the data type. Whether it is mutable, you can change the content inside. Whether it is ordered, all right, that means the sequence matter or doesn't matter. And also whether the items are unique or not unique. So set is like a mathematical set. You can do union and intersection of 2 sets and produce a new set. Dictionary is very interesting. Dictionary literally is, in some sense, our dictionary. So for example, if we don't know the word, what is the meaning of composite? We might start flipping through the C section, find C-O-M and then P-O-S-I-T-E, and then we can look for not just the meaning, but the synonym, the anonym, the pronunciation, the examples, right? So we can do that. And that's exactly what a dictionary data type does. What it does is that it contains a bunch of key values. Key values, right? So the key themselves are data values, which are either a string or integer or float. They are scalar types. Then there is a value that is being associated, and this value can be any data type, including another dictionary. So, for example, if you find what is the meaning of composite, right? Composite might say composite means being composed of, right? Composite as a verb means to try to combine different things into a new thing, new structured thing or whatever. For Chinese understanding of composite, refer to that dictionary. Possible, right? Yeah. So if that's the case, then that is we will have a dictionary that says for composite Chinese, look up for that dictionary to look for the meaning of composite in Chinese and pronunciation in Chinese and so on. Well, that's possible. So this allows us to build fantastic kind of structure that kind of mimics real life relationships between different objects and entities. That's wonderful, right? So just these four composite data types alone already give rise to a myriad of possible intricate relationship building capabilities to link up the relationships between data. And if you think about data as human being descriptions, for example, does he know her? All right. Does this employee know that employer? All those are relationships and very interesting social media relationships, right? How can they be represented or digitized in Python? And now I hope you're beginning to have some idea about, oh, yeah, that's possible, right? Using a sort of paired coordinate. Well, a paired coordinate, the sequence makes sense. You need to be able to change it. Perhaps we use a list, right? And having a list of a pair of two IDs, like two NRIC numbers or two matriculation numbers or two IDs, basically, means that they know each other. So we can build a lot of invisible relationships. Very powerful modeling capabilities can come out from just having these four composite types alone.